I will now demo how to go through our use cases of the Mind Lake SDK. In the current test phase, we are using Goerli train. So let's first make sure that we connect our MetaMask to the Goerli. And then to start from scratch, I will create a new account. Actually, if you want to go through all the, especially for the use case 3, you will need 3 accounts. The process to create the accounts are the same, so I will only demo for only one account, and the other 2 are same. Okay, to speed up this demo, I just skipped the faucet process, and I have already got some Goerli ETH into this account. Now I will register this account on Mind Lake. Actually, we can finish this register process in any of the app which uses Mind Lake SDK. As long as we connect for the first time, the register process will be finished automatically. Now I will choose -scan to finish this register process. This is -scan, and it is a useful tool to get your account info in Mind Lake. Now we are using this tool to going through the registration process. Okay. Simply click the sign in button and connect the wallet. Here we need to sign a message to log in. Here we got a notification from MetaMask. It requires your public key. This key will be used to encrypt your account key. After encryption, the ciphertext of your account key will be uploaded to the blockchain. So it requires some transaction fee to upload this ciphertext. This transaction is used to upload the ciphertext. In the test phrase of Mind Lake, there is not any other fees involved. Now the registration process is all done. This decrypt request is to decrypt the ciphertext and recover your account key so that you can interact with Mind Lake with your account key. Okay, now let's create an access key for the Dapp in this -scan. It will be used in the use cases. Now we have finished the preparation for the following use cases. Let's then go through some basic concepts of the use cases. We have two roles here. One is the developer, another is the users. For developers, they just develop the app, for example, use case 1 or 2 or 3. Actually, in their Dapp, they imported the library of Mind Lake SDK. So their Dapp was able to interact with Mind Lake and then deploy it to some place, for example, some web server or some decentralized storage like IPFS or Arweave. After the developers deployed the app, the users they will be able to access this app by loading it in their library. So the users is able to access the app and log in to Mind Lake and interact with it through this app. Let's come to use case 1 and first take a look at the scenario. In this case, the developer will write an Dapp. This Dapp allows the user to encrypt and upload their sensitive info. When the data is required again, the user can query and decrypt the data to get the original info. This is the data we need to put into Mind Lake. We have 3 columns. Wallet address, this should be public data and not encrypted. And name and balance, these 2 columns are secret and they should be encrypted before they are uploaded to the Mind Lake. These are the code of Python and the TypeScript version. You can find them in the GitHub repository. The 2 versions follows the same logic. If you want to write some data to Mind Lake, you need to follow this process. First connect to Mind Lake and then create a table if it doesn't exist. Encrypt data and insert data to Mind Lake. After that, the data in Mind Lake should be look like this. The wallet address is in plain text, and the name and the balance should be encrypted. To those who do not have the decryption key, it is just some random, meaningless binary data. Now let's run the use cases. I will run the TypeScript version first. First, let's make sure that we have already installed the node, and its version is 16. If not, you can follow the tutorial and install the correct version of node.js. And then let's clone the repository from GitHub. You can get this command line from the tutorial. Download completed, and then let's install the dependency. Dependency is all installed, and then let's check the version of Mind Lake SDK. Now we need to modify the config file of the use cases. We can copy it from the template file. and modify the content. For use case 1, we only need to fill in the app key. We can copy this app key from the mind scan. We generated this key previously. Paste it into the config file and then save the file. We can now deploy the use case to localhost to our own machine now as a developer. The deployment is finished. Okay, now I switch my role to a user. So I open my browser and visit this page by type in this URL address. I click the test case button and click sign message to log in. Decrypt to get the account key, and then I succeeded to interact with Mind Lake. I created a table, encrypted the data, send it to Mind Lake, and then query the data from Mind Lake, decrypt, and get the plain text again. You can find the source code of this use case from this location. This use case 1.tsx file. You can try to modify this source code and see the changes in the web page. I will next run the use case of Python version. First, please make sure that you have already installed Python in your environment. Then use pip to install Mind Lake SDK. The Mind Lake SDK is already installed. Then we need to clone the repository from GitHub. We can find the command from the tutorial. Git clone completed. Now we need to create an env.py file, which contains the account info. We can copy the env file from the env template. Then we edit this env.py file. For use case 1, we only need to fill the wallet info of Alice. Since we don't have MetaMask in Python, we will have to copy the account info of Alice manually from the MetaMask. We can get the address from here, copy and paste. And we can get the private key of the account from here. We need to input the password and get the private key. Also paste it in env.py file. And then we need to fill the app key. It can also be fetched from -scan, just as we did in the TypeScript version use case. A saved file and then we can run the use case 1. Okay, we get the result. We can review the source code of use case 1 to see what happened. We can take a look at the SQL query which outputs the final result. It is in the bottom of the screen. If you still remember the balance column, it is encrypted. Currently, we are actually doing privacy computing. We are querying over a column which is encrypted. In this case, we want to find out the users whose balance is over 15. Since the data stored in balance is in ciphertext, so we need to convert 15 also into ciphertext, and then we compare ciphertext with ciphertext. And we can see the output result. Bob is the user matches the condition. Now we have come to use case 2. But I won't talk too much about use case 2 because it is very similar to use case 1. The difference is in use case 1 it is structured data, and in use case 2 we deal with a picture file which is unstructured data. Okay, then let's just directly see the result. Click the test case button. Sign the message to log in. Decrypt get the account key. And then we fetch a picture from GitHub. Encrypt the picture file. Upload to Mind Lake. And then query to get the cipher. And then decrypt it. Then we get the original picture file. Okay, then let's see the Python version. We get the MD5 of the original picture file. And then we encrypt the file, upload to Mind Lake, then download from Mind Lake, and decrypt the file. We got the MD5 of the decrypt file. The two MD5 is the same, which means the two files are exactly the same. Okay, we have arrived at use case 3. It is a more complicated use case. There are two kinds of users here. Alice and Bob, they are traders. And Charlie, he provides settlement service. The traders, they have the data of transaction. And they are all sensitive information, so they encrypt the data. And since they need Charlie to provide settlement service, they need to grant the data permission to Charlie. They actually need two different Dapps. However, to simplify the deployment, we combine them into one, and we distinguish different users according to their wallet address. So we need to put their wallet address into the configuration. Let's first do it with the TypeScript version. Modify the myconfig file in the src folder. Save the config file and deploy it on localhost again. Data permission can only be granted to existing user in Mind Lake, so don't forget to register Charlie first. Visit the URL of use case 3. In MetaMask, switch the account to Alice. And click Insert Alice Data button. Log in and decrypt the account key, encrypt data, and upload data. Then grant the data to Charlie. Insert done. Do it again with Bob. Switch to Bob. Login. Decrypt. Insert. Grant data permission and done. Switch to Charlie. Log in. Decrypt. We can see what Charlie has done. He combined the transaction table of Alice and of Bob together, and then he ran a group by clause to calculate the sum of each account in all the transaction tables. Now let's run the Python version. We need to edit the env file. Fill in the account info of Bob and Charlie. Save the file and run the Python script. And we get the same result as the TypeScript version.